So far in this course, all we've done is learned how to describe motion. It's largely been mathematics. I want to now turn to the process of modeling. This is a rather deep and creative endeavor, and it's the heart of any science. For concreteness, let's model what happened when you stop a car at a stoplight. What sort of position versus time graph should I draw? What parameters are needed to tell someone else what is happening? That's what we mean by modeling. Not knowing anything else, I probably imagine that position versus time graph would look something like this. For some time interval, I am moving at some constant speed, and at some later time, I am stationary. Okay, and the only tricky part is this little bit in here when I'm actually doing the stopping, and the graph is going to look somewhat like that. That's not, I don't love that. Let me try that again. Look at that. That's nice and smooth. Okay. Given that position time graph, I can make a velocity time graph. And we know the way to do that is I take the slope. I'm just going to draw another coordinate axis under the previous one. And I'm imagining that the times are the same. So if I go down from this point, that is the same time down here. And this point up here is the same time down there. Okay. Well, under this circumstance, the velocity is constant over this time interval, and the velocity is 0 for that time interval. And so again, the only possibly difficult thing is what's happening in this time interval. Okay, and I know that I just have to draw something that kind of smoothly connects these. Now, finally, let's think about acceleration. Now, what should the acceleration look like? Well, I do the same thing. I want to take the slope of that other curve, so I'm going to make some axes again. All right, but now, before I do anything else, I know that I'm slowing down when moving in the positive direction, or in other words, the slope of this is negative. So my acceleration will be negative. So I'm going to draw my axes up high. So now, during this time interval, the acceleration is 0. During this time interval, the acceleration is 0. And in between, the acceleration is negative. So if I wanted to tell you about this model, give you all of this information, I can make a little spreadsheet file with numbers along it and send you all of that information. But there'd be a lot of information there which wouldn't be so important to you. If I think about what are the things I really care about here, okay, what I care about is these times here, where my acceleration, where I start slowing down. I care about this time here, where I've stopped. And I care about, how rapidly I decelerated. Okay. And so the kind of minimal model, which is going to contain those three parameters, is to just approximate this acceleration as a constant. Is that model exact? No. Is it useful? Yes. The thing that makes it useful is that I've gone from having an infinite amount of information I have to tell you to just those three numbers, T1, T2, and A. Okay. Are there questions I could ask about this system which my model will not be able to answer? Of course, right? And so when modeling, You want to have enough detail in your model that you can answer the question you're interested in, but keep it simple enough that you're not overwhelmed with all of the details. And so I could use this model for various things. So, for example, suppose I put new brakes in my car. You say, how should this model change? And you might say, well, if I have new brakes, then I can stop in a less time. And so this acceleration here, that could be more negative. Right? And I could compare two cars based on how quickly they can stop. All of those things. So it's a useful model. Right? One of the philosophies of physics is try to find the simplest model which can be used to quantitatively describe the physical system. There are jokes about physics models which begin with, assume the cow is spherical. Clearly there are times when you need to be more sophisticated than that. And, having that mental picture of a cow which is literally spherical is ridiculous. But there's a real pride in finding particularly simple ways to understand nominally complicated situations. Okay, so then after coming up with a simple model, such as this one tries to extract as much understanding as possible. Constant acceleration models are so common that we're going to spend a significant time studying the mathematics of motion with constant acceleration. I want to emphasize, though, that we're working with models. It's rare that an actual physical system has constant acceleration. Nonetheless, learning how to understand the mathematics of that situation will be extremely valuable to you.